So I'd like to thank everyone who's joining us today. So welcome to the CNCJ November meetup. My name is Harry Lee. I'm the organizer of CNCJ. Today we have Jose joining us, who will be sharing his team's cloud native journey. Okay, so just a few housekeeping items aside. This session is scheduled for an hour, or in this case, will be scheduled for less than that. However, we will leave the Zoom meeting open if people would like to continue their discussion. The session has a technicality rating of 2 out of 4, so there may be some communities terminology, but Jose has agreed to keep it as minimal as possible. Questions are always welcome, but please keep them on topic. So we want to make the session as interactive as possible, so everyone will get a chance to speak. You can also ask your questions in the chat panel in case that you think that you might forget about it. There is a reaction icon in Zoom that we've just discovered. If you want to raise your hand, please click the reaction icon and give Jose a thumbs up, and then I will give you the chance to speak. This session is being recorded and moderated, so please be respectful towards the speaker and your fellow participants. You will be kicked out if you do not abide to our code of conduct. This session will be available on YouTube under the official CNCF community YouTube channel in the next few days. So with that, I'll hand it over to Jose to kick off today's session. Yeah, Jose, the floor is yours.
Awesome, cool. Yeah, so the title, yeah, if it ain't broke, rewrite it. So before I get to that, let me just say a little bit about me. So I'm the technical lead at Standard Bank, specifically the ALCHEMY team. So what ALCHEMY does is we are one of, I'd say, 3 trading systems on the global markets team that is basically a front office system. So we do trade booking and that sort of thing. What this session is about is I want to share our story about how we turned our monolithic application into something that's a bit more, well, not a bit, quite a lot more scalable and way more reliable. So besides the technology, there was also some sort of soft issues we needed to deal with. There was a lot of team culture we needed to create. That was quite important. So yeah, that's what it's about. So this is just a little bit about me. This will probably be recorded. So here's how you guys can get a hold of me through Gmail, Medium, or Twitter. You can see that old Twitter bird is sideways. I like him looking like that. It looks a bit more like Batman. It's pretty cool. Let's just go look at that again. That does look like Batman, right? Yeah, so ALCHEMY is a trading system. We book all sorts of exotic trades in ALCHEMY, and it's what sort of differentiates us from the other trading systems where they would book vanilla sort of trades. And when I say trades, that would be like your foreign exchange swaps, or, you know, if you do if you buy currency through the Shift app or something like that, that would be a vanilla type of trade. It's very standard trade. Or if you buy a bond or something like that, that's standard sort of trades. With ALCHEMY, what we do is the more exotic stuff. And what that means, they structure a whole bunch of different trade types together, and then we need to value those trades. And that takes a lot of market data and quite a few intense C++ models to do that. The system also does reporting and then sensitivity. So what that means is we take the market data that gets thrown into the system and we shift it up and down, and we check what's going to happen to this trade's valuation if the rand goes up, for example, or the dollar goes up or down. So that's what the trading systems do basically, is they allow the Standard Bank trading desks to hedge against various risks across different countries and even within South Africa. So again, ALCHEMY is probably responsible for, well, ALCHEMY, when I say ALCHEMY, the system supports the structured solutions desk, and the structured solutions desk is responsible for like financing things like ESCOM or other counterparties and things like that. So what went wrong with ALCHEMY, or where was it at a point? And that's where I'd like to start this journey, or this talk about our journey, right? So initially ALCHEMY was a monolithic application. That means that every deployment we had to deploy every single artifact. And that was basically one giant EAR file. So the application is written in Java. The application server itself is JBoss. So we would create an EF file, drop it into the application server, which is JBoss, and then also build the client application as well. The client application was tightly coupled to the monolithic app service, which meant every single deployment we had to deploy everything. And deployments are happening manually, so there was obviously a lot of operational risk in doing that sort of thing. There wasn't a lot of stability, but the trading system was doing what it was meant to do. It was valuing trades. People were able to book new trades, and people were able to get new trade types into the system, reasonably quickly. And that's another thing that sort of differentiates ALCHEMY from the other trading systems that are found in Standard Bank, is that for trades that need to be booked quick for some sort of competitive advantage, ALCHEMY is the sort of go-to choice. And then eventually those models get migrated into the more vanilla systems. And that's pretty much why it still exists today. So it's a low volume system, but there's complicated models and stuff that goes into ALCHEMY. Going back to the monolithic part of ALCHEMY, obviously the risk in the deployments and stuff, especially when you're doing something like deploying all of this stuff on the screen now. There's JBoss, there's some queues, there's compute nodes, and then various client applications. Not only do we need to deploy the actual ALCHEMY client application every time we did a deployment, but also plugins to Excel that traders just love. There was also some RESTful services that needed to be updated. So everything needed to be updated all at once, making this thing a monolithic application. So what did we decide to do is, first we decided to take the manual part of our deployments out, or at least our builds, by introducing continuous integration. What that is basically is every time we commit code, we would have an automated build that would verify the code, do some tests on the code, and then create those artifacts for our deployments. Initially, the system that we used for our continuous integration was Jenkins. Well, actually it was Hudson, eventually became Jenkins, and the code repository was Subversion. So once we had automated our builds, what we started to get was some sense or some predictability, some sense of whether or not the code is stable. Instead of running around to all the developers asking if they had committed some artifacts or committed code that needed to be deployed, we had a centralized system that everybody was committing to, and that code was getting built automatically for us. So the trust in our deployments increased, and already at that point, quality started going up, as well as reliability. So what that did for us is kind of align our business with the developers, and it allowed us to start to innovate a bit more. So now that the business had trusted us with our deployments, they kind of gave us the freedom to start innovating a bit more. Whereas before this, when things were kind of unstable and not as reliable as we'd like it to be, the business kind of, wanted us to focus purely on getting the products out there, and that's it. Don't mess around. Just, the thing kind of works now, so leave it alone. After continuous integration, they started to trust us because the application server wasn't going down. During deployments, we didn't have to ever roll back or anything like that. We knew exactly what those artifacts were going to do before they actually got there. And so we built up trust. So in a sense, this was sort of our refactoring or our rewrite journey as well, is because we started introducing additional technologies to enable us to innovate. And part of the headline of this thing was to inject innovation, and this is how we kind of did it. It was to build trust between us and our business. One other thing that we introduced was obviously following an agile sort of approach. The current sprint patterns or iterations at the moment are 2 weeks. We also deploy artifacts every 2 weeks. So what will happen is we'll start development at this point, iteration 1. For 2 weeks, we code. And at the end of iteration 2, we create an artifact and we deploy it to a test environment. Sorry, dogs are killing each other. Once it's in a test environment, we kind of test it for about another 2 weeks. But at that time, the next iteration starts and we start taking on new work. So at the end of iteration 2, we'll deploy the first iteration's artifacts, and then that makes it to production, and it's pretty stable. It's gone through like 2 weeks of testing, 2 weeks of pure regression. So we haven't had a rollback in I don't know how many years. I think it's probably about 10 years. so it kind of speaks for itself. So with that, we kind of saw that we had a contract with our business. We gave them predictability in terms of when artifacts would make it into production. And then they gave us the freedom to start to innovate. So because they would join our prioritization meetings, discuss items that they needed, we would take it away, feedback to them which items we actually had capacity for, and then they would know for certain, or some degree of certainty, that those artifacts would make it to production. Some cool beeping. So, yeah, so where was I? Yeah, so those artifacts would make it to production. That was our contract with them. And now we had the freedom to start pushing our technology a little further. So it wasn't enough that the technology kind of just worked. We wanted to make it work a little faster. We have an end of day process where reports kick off, and it takes, well, it used to take like, I don't know, 20 hours to complete. And, you know, we wanted to bring that sort of thing down by a significant amount so that before the traders left home, they could get all their risk numbers. What would happen is we've got a whole bunch of valuation reports that run valuations on trades and then do certain sensitivities overnight, and they would shift market data and then revalue these trades. And that operation takes quite a long time. We run on MATLAB and C++ models. And when you've got like 35,000 trades or something like that, and you have to revalue these things for every bump in market data that you do, it takes quite a lot of time. So we wanted to bring that down, and we needed to increase our scalability or our performance in order to do that. So we basically started, we set up two streams of work. One was purely focused on business, and the other side was just innovation. Every time we started an iteration, we would ensure that somebody was working on some sort of innovation type product, either rewriting some sort of code or introducing new frameworks, better technologies, something like caching to make loading of trades a lot faster instead of going to the database each time that would be sitting in memory, you know, that sort of thing. So our innovation stream took us to a place where we found out about Docker containers. So I think Docker came out around 2014 was the first sort of production ready release. We adopted it in 2015, probably, where we started messing around with it and just seeing if it was something that we could use. And we found that it was great for setting up like integration tests. So we could run multiple integration tests where we spin up an entire environment, and that would be the whole monolithic environment sitting in one Docker container. If you don't know what a Docker container is, think of it as a very lightweight virtual machine. We would spin up these lightweight virtual machines or containers and run tests against them. So we found it helped our continuous integration pipeline like quite a lot. Just going back to continuous integration, I always find like seeing a picture of the thing looks kind of helps. So this is basically our pipeline for a build, where we do the build, we create some containers, we run some tests, and at the end of it, we get some sort of artifact. That's basically continuous integration. As soon as you commit something, it starts a pipeline and carries on with your build. We'll get to continuous delivery in a sec. On the business side, we kind of carried on with model integration. What that means is if there's a new product type, like a new sort of bond or something that we need to model or calculate, we would integrate those C++ models into our Java code base, and then those get executed in separate compute nodes. So we farm off those calculations to these nodes. And that's been happening even since the monolithic application. We had some nodes that we had to run, but those nodes weren't very efficient. And we couldn't sort of scale those nodes up and down. Okay, moving on. After we had discovered the power of containers, we decided to move our entire code base from Subversion to GitLab. So we wanted to sort of leverage the power of Git. Most people know about GitHub, but GitLab is another sort of Git repository. What Git also offers you is a place to store your code, but as well as run tests and builds and so on. So it's one sort of integrated package for CI/CD, which stands for continuous integration and continuous delivery. on the business end of things, we found that we lost a lot of time messing around with UI and that sort of thing. So whenever a trader had a new, weird and wonderful trade type, he would tell us, okay, he needs to add these certain properties and he wants to make the thing pink or blue and he wants to make it all pretty and stuff. What we decided to do is create a new UI framework where we didn't have to mess around with UI. We could focus on code and then our UI would be auto-generated. So we built a UI framework where we would annotate those properties. And I think it's pretty cool if I had to show you just a little sample of it. So here's some Java code, and we can see, here's what I mean when I say an annotation, is that there is a field called reference day count, for example, right? So we annotate it and say, this is a UI property I want to see. And then when we build the code and our UI gets generated, it ends up with something like this, where you would get a reference index or a reference day count. So it knows how to generate its UI based on those annotations. So what that did for us, not to stick too much to code, is it allowed our UI to be auto-generated and it's freed up our time. So we would focus on the business objects, the model integration, and continuous delivery. So we'd ensure that we pump out all this code and get our trade types to our traders as fast as possible. And the naked objects pattern is what made that possible. Naked objects kind of describes that pattern where you annotate what you want to render, and then something happens in between, and then your UI gets rendered. That something happens in between parts is what takes our code and renders that thing. So we created that piece in the middle that follows the naked objects pattern. I don't know if there's any questions up to now. I'll move along. So here's just an example again of our UI and naked objects in work or in action. So here we have a trade in ALCHEMY, and all of these properties that you see here are auto-generated by our framework. So new developers would just annotate something and say, yes, it needs to be a UI property, and then it gets generated. So even tabs and drop-down boxes, if it's a list or something, the UI framework recognizes that it's a collection and it will give you like an option list. Over here is a bit more advanced UI object where we take a whole bunch of trade types and we generate these tickers for them, and as well as the graph. So even the graph gets annotated in code and gets auto-generated at runtime. So that greatly sped up our delivery of these new trade types, which is what makes ALCHEMY special or different from most other trading systems, is our time to delivery. Here's another example of the UI. So not focus too much on that. So once we discovered containers, we started to mess around with Spring. So a newer version of Spring came out, which offered a lot more than previous iterations of Spring. So around, I think it was version 4, we had adopted it. And we started to look at breaking up our monolithic application into smaller services that made it possible to deploy only certain sections of the code. So we don't want to rebuild everything. We wanted to deploy just maybe the UI, or we wanted to deploy the compute nodes on their own, or maybe even the risk engine itself. So take the risk engine, which is what does the sensitivities and bumps market data and stuff, and then deploy that on its own without deploying everything else. So when it comes to continuous integration, which is just building and running tests, the next step is continuous delivery, which is the CD part of CI/CD. What we decided to do is apply that to our test environments. So whenever we deploy, whenever we commit new code, we would get a new build, we would run tests, and they would automatically get deployed to a test environment like QA or staging or something like that, without us needing to click, deploy now or something. So as long as all the tests pass successfully and the build doesn't fail, it will get pushed into a new environment. I mean, obviously, because it's a bank, production is a bit of a different story. We need to go through, we still need to go through a few approval processes to push things to production. So our CI/CD pipeline kind of ends at staging. To go to production, we need approvals, and then our CI/CD pipeline pushes it into production. So at this point, we started messing around with Spring, breaking up some services to see if it was, if we could create microservices out of it. This was before microservices became like the big buzzword. We kind of just happened to fall within a microservice pattern. But we still kept JBoss alive. So our production was still running on JBoss. People were still getting warm and fuzzy feelings with JBoss deployments. So we kept it alive for a while as a separate stream. But our CI/CD, specifically GitLab, allowed us to branch very easily and create these two streams where it was services running using Spring and services running using JBoss. Okay, so at some point, we decided to reduce the work that we were doing on JBoss. So effectively take all our resources that focus on Spring and then create a purely microservice sort of architecture where all of our services could live on their own. We would deploy these microservices using those Docker containers. So it means that we'd start up these containers that were running each of the services, and they would start talking to each other using things like RabbitMQ or RESTful protocols. It's just a way of talking to each other. I'm sure people know what REST is. But that in itself became quite a challenge. So once you get to a point where you've got more than, say, 10 microservices, or maybe even less than that, it becomes quite a challenge to start deploying these things and coordinating those deployments. So what we started to use was the tools provided by GitLab. So we started using GitLab with Ant. Ant is just like a tool that you can use to copy things or deploy things, or do like very specific tasks. So we started using Ant for that, but it was quite a challenge. It was quite a mission to maintain. We had to maintain a whole bunch of build files. For example, this is one of the build files that we had. These files call additional build files. So you see when it does like an Ant call, it would do something like a Maven, which is a build tool. But sometimes it would call into Ant, which is like another kind of tool to coordinate things, like this one up here, which calls a different build file, which has a whole bunch of other instructions, and that gets quite messy to maintain, and even version and that sort of thing. So we got stuck at that point for quite some time, and we didn't push it to production yet, just because of this challenge and this inability to keep it clean. Maybe that's the wrong word to say, but yeah, so maintenance was quite an issue. So moving forward, we had to find some solution to this problem, and that's where Kubernetes came in. So Kubernetes, you can think of a way to coordinate all these little containers that need to talk to each other. They all sort of live on a plane that is able to manage them and update them and also scale them. So what Kubernetes can do for you is if you package everything into a container and you say, okay, my service is running low on resources, or I'm getting way too many connections to the service, Kubernetes can upscale that service. So you can natively just say, like, if this thing reaches a certain threshold in terms of CPU usage, scale it up and maybe cap it at a certain limit. So Kubernetes did that all for us. What we found was Kubernetes itself is pretty awesome once it's set up, but setting it up on bare metal at the time was quite a mission. So what we did, we set up a cluster on somebody else's infrastructure that already had a Kubernetes cluster running. So you need a Kubernetes cluster that scales or that spans across various machines. And when you deploy your little containers to those Kubernetes clusters, it will manage them. So it will manage the scaling and all that for you. The definition for your containers and stuff is stored within YAML files. And that will, kind of say how many resources you need, what sort of storage you need, and that sort of thing. So these YAML files can be shipped with your build, and it makes it a lot more maintainable instead of having one Ant file that describes your whole build, which is very messy. So the next tool we wanted to do is to manage the actual Kubernetes deployments, and that's when we got to Octopus. So Octopus is another tool that we use that basically talks to Kubernetes and pushes our artifacts from our GitLab GitLab builds into Kubernetes. At this point, as luck would have it, the business came up with a mandate that we all needed to be running on cloud. So once we had basically got to our Kubernetes cluster, as well as our ability to deploy these things quite easily, through Octopus, for us to switch to cloud was very easy. We first started with something that was local. So we hijacked a couple of servers, so bare metal servers, meaning these servers had basically nothing, but they were physical machines. And we set up a Kubernetes cluster on it. The tool that we used to set up the cluster, because setting up a bare metal Kubernetes cluster, so taking a fresh machine and installing Kubernetes is quite a mission initially. I'm sure it's a lot easier now. But what we found is there was a tool called Rancher, which is basically a Docker container. You start up the Docker container and then it creates a Kubernetes cluster for you. And what Rancher kind of looks like, you can access its sort of management portal and it will look like this. So Rancher is running on one of our machines locally, and there's a whole bunch of containers running on these things. You can go into one of these and then scale it up by creating more instances, but it will basically give you the state of each of those containers. So Kubernetes does that as well. It also has a dashboard, but what Rancher gave us is the ability to create a Kubernetes cluster, and it's as simple as starting a container. So when you start a Docker container, you basically would say something like Docker run something, and in this case it would be run Rancher, and then Rancher would start up, create a whole bunch of things, and then you'd go into the dashboard and say, cool, I've got this new cluster, or do you want to name your cluster, and so on. And then you access your cluster the same way as you would a normal Kubernetes cluster. So all that work that we had done for Kubernetes still applied to Rancher. And even our Octopus deployment tool could just now point, instead of to the bare metal Kubernetes cluster, could point to the Rancher Kubernetes cluster. So the reason we decided to go with a bare metal solution instead of going straight to cloud is we wanted to get some sort of benchmark for performance. Like I mentioned earlier, there's some nodes that compute, we call them the compute nodes for ALCHEMY. Those nodes basically run the C++ models as well as the MATLAB models. And if we have more nodes, we can take on more calculations. So what Kubernetes allowed for us is when it saw there was a whole bunch of reports running, it would issue a whole bunch of work to these nodes. And then they would obviously just subscribe to the like a message queue or something, take on the work, compute it, and send a result back. So Kubernetes allowed us to create more nodes as we needed. And then at the end of the report run, it would scale them back down so we don't take over the CPU for no reason, right? And that model sort of fits what you'd want to do in cloud, where you want to scale up and scale down when you don't need the actual compute nodes. So after we had our benchmark, to get to cloud is very easy. We used a AKS cluster on Azure as a test, and then EKS on AWS. And there was even an attempt using OpenShift, which we kind of moved away from. The AKS deployment was successful as well as the EKS. So we kind of found that our solution kind of worked natively in cloud. It worked well, and it was easy to deploy and also easy to scale. And that was the main focus, was to be able to scale our compute cluster. So at the end of this, what we had is a solution that was scalable. We had a reliable deployment model, and we were able to also innovate while delivering on the business requirements. And it's what we do now, still. So every time there's some sort of new technology we think might be useful, we start messing around with it, and then we integrate it into our architecture. So what we ended up doing throughout this journey was essentially rewrite the application without disrupting the business side. So we had an idea to introduce reliability and scalability and so on, and we incrementally did it. So we followed a marginal gains approach, where we want to fix little issues whenever they sort of rose up, not sort of fix everything one shot, but incrementally add new features or add a new framework and sort of move towards a goal. And each time we got a goal, we move further. So we have scalability, and now the next step is we want to obviously reduce our footprint, so ensure that we run our models a lot more efficiently without needing like a million nodes, as well as offer our services to other areas within the bank. So our risk engine, because we have taken it out and created a service out of it, it's actually able to service requests for other areas within the bank that need this risk engine capability. So if they need to see what will happen to a FX trade should the rand go up or something like that, they can pass those queries into our risk engine and get some result back. So our risk engine now can scale for other users as well as for its core users, which is the ALCHEMY and the Structured Solutions Desk. This is just our UI showing a whole bunch of nodes that are currently running. This is like a typical end of day report run where all the nodes will be active, and then at some point they all just die and they become inactive, which is shown here, but they still stay alive. So after the Kubernetes was introduced, now these nodes start falling away, so we're no longer using the full compute cluster, and other people can probably use it, which is pretty cool. So our new structure looks, still there's quite a lot of components, but all the components have been microserviced. So the smaller services for the risk engine can live on its own and can be deployed on its own. We use RabbitMQ to do a lot of the communication between the risk engine and those compute nodes. We also allow the compute nodes to take on either C++ or MATLAB or even Java models. And we can create nodes specifically for those instead of sharing the nodes, which makes it also a bit more efficient. We use a cache like Redis cache on Azure or even AWS or even locally. We still serve the same clients, which is the actual application and various REST applications, as well as the Excel stuff using a SOAP protocol. But whether it's on the cloud or on bare metal, the architecture stays the same, and it can sort of jump between infrastructure. This was our initial cloud journey. This slide means nothing. It just looks cool. There's something that's going up. Any questions? I kind of sped through the whole thing. That's my other go-to nervous response is talk fast.
I think Anish has a question in the chat. Are you using Spring or Spring Boot?
So we're using Spring Boot to start up the application now, specifically the risk engine. I see the Spring framework there's tons of components to Spring, but yeah, Spring Boot that we're using. I think we're on version 5.4 something, 5.4.1, I think. Let me see if I can open the chat. Any other questions? So just another comment from me is what sort of allowed all of this to happen within especially a banking environment was to build up trust between us and our business. So within most banks, what will happen is, the business kind of drives the technology decisions, but we managed to build enough trust that we could flip that around and let the technology people drive technology decisions. So what our business wants basically is something that is reliable. They want their tasks or their requirements to be met within a certain time frame that's predictable, and that's about it. So if we can meet that and we meet it consistently, then doors start opening up for the tech guys, where they don't mind if you sort of messing around with newer technologies and rewriting things without them really knowing you're rewriting it. And what it also does for the tech side is we retain a lot of people, right? So if you sort of day to day supporting the same system, doing the same thing, integrate the model, go home, and it's the same thing tomorrow again, you start losing people, right? Especially developers. So developers love new technology, and it's difficult to find places where you can introduce that new technology. So what helps is having control over what technology gets introduced. So that's the first step, is building up the trust between you and the business. And then once you have that, and then you can certainly help, or it certainly helps retain people. We've had, I think I've been in the team for about 12 years already. And there's probably 3 or 4 of us that sort of match that sort of time frame. And there's 1 or 2 new people that have already been there for about 6 years. And we're getting 1 other person. So our retention rate is pretty good. And it's mostly because we get to mess around with the stuff. So if I take any one of the developers within our team and I ship them off to somewhere else on the planet, all the new sort of stuff that's out there won't be completely sort of unknown. We tend to mess around with a lot of the new stuff when we can, and we don't introduce it just because we can. We introduce it if it makes sense, obviously. But we have the freedom to sort of do that. So yeah, building that contract between you and your business, I'd say, is probably first step. And to get to that step, you need to introduce reliability. So there is I don't want to talk about SRE, but there is a new drive towards SRE, which is site reliability engineering, which basically allows you to set up a budget, like a deployment budget or an error budget. So I don't know if it's called an error budget, but you specify how much time within a certain time or span, maybe a year, are you allowed to do deployments, and then they call it the nines, or the 3 nines, which is like 99.9% uptime or whatever, which gives you a certain amount of time during the year to actually do your deployments. And what happens when you set that up, so you set up these error budgets, is you can basically deploy whenever you want with one restriction, that you within that error budget. So they don't care what you deploy, or if you roll back or don't roll back, as long as you're within that sort of time frame, it's okay. So without realizing, we kind of were following that pattern where we would have set release and deployments. So even if we had to roll back, as long as the changes get there eventually, and like I said, we haven't rolled back in many years. So changes that we make usually get there. But should we roll back, it doesn't matter as long as we're within that sort of error budget. And I think that's also important. And we sort of inadvertently sort of follow an SRE pattern. SRE is sort of just another implementation of DevOps, where you get operations and dev working together. So if you think of, when I say implementation, if you say BMW implements car, I would say SRE implements DevOps. So it's just another implementation of DevOps, which is also another buzzword that was sort of making rounds. What also helps in this whole framework is the ALCHEMY team supports the system. So we are the devs, and we are the support, and we are the infrastructure deployment guys. So any one of us is able to deploy any part of ALCHEMY, and any one of us is able to support that component. So should something go offline overnight, whoever's on call, and it's one of the devs, we will support it. So what that does is it kind of helps build reliability into the system, because nobody wants to get a call at 3 in the morning. Yeah. So having your team supporting your system kind of helps.
Yeah, definitely. So thanks for that, Jose. So I see that there's 2 more questions from Anish. The first one is, how complex was migrating your test setup to Kubernetes?
So let me go back. So once we had containers set up, we migrated. So we initially had tests running using JUnit, and it was sort of just running during our build as a Java JUnit process, right? We took all of our tests and we containerized them at one point. The first tests to be containerized were our integration tests, but later on we actually containerized every single test. Not test on its own, but test pack, I'd say. So even our regression tests, our unit tests, and our integration tests became containers. So once that happened, running them on Kubernetes was basically straightforward. As soon as you got things in containers, putting them on Kubernetes is like a one-line command that you can kind of run. So that's what we did. We wanted to run everything in Kubernetes at one point, and to get there, we had to containerize things. And yeah, we first started containerizing integration tests, but eventually we containerized everything. So even on that last slide where you see the risk engine itself, that's containerized. So everything runs within a container. And that makes the deployment way easier. Even like tearing down things and redeploying and doing sort of blue-green deployments and that sort of thing makes it way easier once things are containerized and not running things within Kubernetes and certain things outside of Kubernetes. Yeah. So yeah, I'd say containerization is first step, and Kubernetes is cool, but like what one of these slides says is it's basically just an orchestrator, right? And thinking of as just the orchestrator kind of helps you build everything before that so that it can be orchestrated. So if Kubernetes one day, you know, becomes something else, or there's some other cool thing that's similar to Kubernetes, it's fine. You can evolve into that. At the moment, we use Kubernetes because it's pretty awesome. Like it does its work. It helps us scale and tear down things when we need to, and that sort of thing. So that's fine. But I'd say start with the smallest components, which is the actual containers themselves, or processes, I suppose, is smaller. But start containerizing things, and then moving over to Kubernetes and running tests, and it's like a non-issue.
Awesome. Cool. So his second question is, do you A/B test the models before production?
Do we? Sorry?
A/B test. Do A/B testing on the models. I think he's referring to those C++,
Yeah.
as well as the MATLAB jobs running on those compute nodes.
So yeah, we test. So our tests, so our regression tests test the models. The only test that we kind of run is we've got a thing that we call a ABT file, which is basically a scenario for the actual C++ or MATLAB model. So we define a whole scenario for those models, and then that scenario ships with the test pack. So we run the models in a test as if it was in production. I could say that. So when our quant guys give us a model, so the quant guys are the guys responsible for doing the maths and producing these C++ files, they'll give us some sort of scenario. We replicate that scenario and we ship it as a test pack within our containers. Yeah, I don't know if that answered the question.
I think so. Guys, if you guys have any questions, you guys can just chime in, hey?
Yeah, sorry, I have a question. I really like the idea of incrementally adding new features, that approach that you took. And I think it's really incredible how the team is able to keep the lights on while fundamentally moving onto a new infrastructure. And you talked about setting up the contract with the business. How did you approach that initially? Like, how did you convince them that you want to start this journey?
So our goal was at first, like I said, when we had the monolithic thing initially, you know, the system would have little bad moments where it would go offline, or deployment would go kind of bad after a while when somebody realized they forgot to add a feature or something like that. So we took it on ourselves to increase our reliability just for us, right? So we wanted our builds to be more stable. We wanted to know exactly what it was that was going to go into production on a certain day. So to do that, we had to start with ensuring everybody was committing to the same place, and that same place was being built every time a commit happened. So that was the sort of continuous integration principle. Once we had that, and we started seeing for ourselves that our builds were a more reliable and more stable, we introduced Agile, and then we approached the business and specifically our traders, and we said, look, we want to look at some other stuff, some innovation type of stuff. We want to look at how we can scale the application. But at that time, our production releases were very stable. And I'd say after about, say, 3 months of really successful, stable builds, they were more open to the idea of us messing around with newer technology. So it started off with us saying, we want to reserve a certain person that will just do innovation type of things. Not the whole team, but just this one person. And that one person will rotate through the team. So everybody had a chance to become the innovation person. And what we wanted to do is that person would go off, investigate some sort of new technology, maybe Docker or whatever, and see if it was viable or if it could fit, you know, within our architecture. So our ask for the business was initially, can we allocate some time for one person every 2 weeks to do that? And they were on board. Where we are now is we don't ask anymore. We kind of just see what is the task that the business requires, and we go, cool, we have prioritized, or they prioritize certain tasks, and we say, cool, we can take on these with the capacity that we have. And then they'll be like, cool, that's fine. You know, we need these things. Or if something's more urgent, then maybe our innovation kind of takes a back seat. But usually we deliver on the business tasks first, and then we jump over to innovation things. So I'd say, like, even now with COVID, we thought that we'd struggle a little bit, especially with collaborating when it comes to newer stuff. But what we do is, like, on a Friday, we kind of all get together, we share a team session, and we all go off and try and achieve something. So, for example, we wanted to, what was the last one we did? We wanted to use something like RabbitMQ to talk to the nodes so that they would be, you know, they would subscribe to RabbitMQ instead of doing a sort of poll pattern where they would poll for new work. Instead, they would be subscribed to new work. And then we'd all sort of sit in a team session until we kind of get it right. And that was after we had completed all the business tasks. So we don't need to ask the business if we can, you know, have someone that's rotating, doing innovative stuff. We just say, as business, what is it that you need? And then we'll get it done. And then we'll make sure that when we define the amount of capacity we have, that we sort of build in a bit of fat to allow for this innovation stuff. So we don't take on too much work, but we don't take on too little that we're not delivering value. I hope that answers your question.
Yes, that was great. Thanks for the answer. I think it's really cool that every time you speak about your team, you have so much passion and so much joy. So I think, I'm sure as your team member, yeah, it sounds like a cool team.
Yeah, I think we probably see each other more than we see anybody else. So it's almost like it's like a family thing. So that's the other thing I mentioned way in the beginning. I said the culture is sort of important. I think what we do when somebody new joins, we have this evil thing that we do where we chuck them in the deep end, right? And especially if it's a very arrogant person. So everybody as a developer, we want to believe we know everything, but deep down we know we don't know everything, right? So what we try and do is dig in and grab that person that doesn't know everything and bring him to the surface, right? So we chuck someone in the deep end, and we make them suffer quite a lot, you know, like to the point of nervous breakdown until they ask for help. And then we kind of explain, look, we also don't know this stuff. Like, we had to learn this stuff. We Google this thing, you know, a lot of the stuff that we've learned, we've Googled, or we've gone on courses or something like that. Like, nobody knows everything, and it's okay to Google and it's okay to ask. And that's what we want to bring out of everybody. Like, it's okay to F up. I saved you a beep there. It's okay to F up every now and then. And all of us have done something terrible in production where, you know, because we supported, be able to fix it or whatever. But it's happened to all of us. And that kind of brings everybody to the same sort of feel, like level playing field, where it's okay to ask questions. It's okay to help somebody. And it's okay to mess up. So that's, like, I think, like, a big part of the culture is that trust that we've built. And like, if you had to sit with a team, like, there's no PC thing. Firstly, like, everybody just says what's on their mind and then we deal with it. And there's no superstar where, you know, it's only this person that's the UI guy, or this guy's the model guy, or whatever. Like, everybody needs to learn how to do everything. So if I get hit by a bus, the next guy can kind of carry on. And my dream has always been, like, if somebody approaches the ALCHEMY team and asks for something, they need to be super confused about who's the person to ask, because, you know, it's very blurred. Like, everybody can kind of do any part of it. So I've always liked sort of flat structure. Like, I say I'm the technical lead or whatever, but, you know, that can be anybody. Everybody runs with a certain task. Yeah. So culture is very important, and sort of breaking down these barriers where everybody thinks that they're a superstar and they know everything. That's important. We need to make sure that everybody knows that, you know, we're all human, we all make mistakes, and we don't know everything.
Yeah. So mentioning of culture, actually, I have a discussion point. So the culture in your team would be cool and stuff, but we all know that business is a completely different entity, right? Would you say that you know, your culture kind of exudes and influences them, or is it still like they're like a sort of like a fine line separating your team and the business?
So I think what happens is, initially the business seemed very far away. So they were like these gods that were doing weird and wonderful trades, and they knew some math stuff, and it was amazing. But what we've started doing now is whoever gets a task for a trader specifically, we discuss things with them. So we've kind of even blurred that a bit. So we know that they are the traders. They know a lot more about trades and stuff than we do. We know the tech stuff, but we know where that differentiation is. So we know that they know a certain thing, but we also know a certain thing. But together, we make a hell of a system, right? So a lot of the times when we get some sort of a task that's requested by a trader, the person that takes on that task will start a session with the trader. And when we were obviously at the office, they would go down and speak to the trader and see how they would implement it. And through that, we learn a lot. Like we've learned a lot of financial stuff where a lot of us were pretty useless when it came with financial stuff, right? We knew the code and technology, but when it came to finance, we suck. But now we sort of learned a lot from them, and that's by interacting with them. And they've learned a lot about the technology. So they know the limitations and they know what it's capable of. And that's come from us speaking a lot to them. So they don't come with insane requests. Like if there's some UI limitation, which there might be sometimes because it's such a generic framework that generates itself, right? They know there's certain limitations and they work within those limitations. So that relationship has sort of come a lot closer. And it's because of the interactions we have with them. And because we support the system, and whenever there's issues, we talk to them about these issues. So we know it's a separate entity, but it's still part of ALCHEMY. It's just this other part of ALCHEMY. I don't know if that answered the question.
Yeah, it does. Thanks, Jose. So I think this sort of trust needs to be kind of nurtured and built, right? And what you've shown us is your journey towards that. In the beginning, we actually have to set up proper, release requests, perhaps, to set up that cadence in releases to now, which you can just like you said, you can just deploy, whenever you want, that sort of thing. Like that journey, I think, is also what is behind this culture between you're able to speak to business like they're your buddies and that they can speak to you the same way, where you have the common understanding. So I think, yeah, this is very cool what you guys have achieved.
Yeah, and one of the approaches, like I said, I think I mentioned it, was marginal gains. I read a book, I can't remember the author, it was James somebody, where he speaks about marginal gains, and it's about little incremental changes that you make to get to your goal. So the example that he gave in his book was something about cycling, where he wanted to win the Tour de France, and people thought it was impossible for his team to do it. And all they did was improve small things. So they improved like the saddle on the bike, then that gave them a few minutes advantage. And then they improved the handlebars, and then they improved certain tiny little things. They didn't just say we need an amazing bike. They improved the bike that they had, and slowly, incrementally sort of added new things that got them to that end goal, right? So our end goal is not to keep a system and just maintain it. Our end goal is to enable our business. It's to make it so that they can trade and they can do reporting insanely fast. So where that happens, it doesn't matter. As long as we know that that's our end goal, is that performance and that reliability, we can make incremental changes to get there. And we're not sort of locking ourselves down to an ALCHEMY product. We're locking ourselves to that end goal. And it makes it easier to see what sort of small changes we need to do to get there. And that was like, introducing CI, and then introducing containers, and then switching from JBoss to Spring, because now Spring makes more sense when you go into sort of microservice. You don't want to spawn up JBoss instances for every service. And then you want to, do something else. But it's those little steps that get you to that main goal. So, and you got to kind of throw out the notion of, we are just the ALCHEMY system, and the ALCHEMY system looks like this. It's not that. We are the ALCHEMY team, and the ALCHEMY team delivers something. We deliver trades, and we deliver fast reporting and reliable reporting, something like that, which will be different for everybody.
Yeah, cool. Thanks. So Anish has another question. He asks, do you have manual UI testers, or is that automated using something like Selenium?
So we use Robo, it's an Eclipse tool. Oh, so that's the other thing. So our platform is built on top of Eclipse. So we use, I can't remember the name now. It's Robo something that does the testing for us. Sorry? Yeah, Robo something.
Yeah.
Yeah. So there's a framework that does the UI testing for us. So it basically spawns up an Eclipse client, does some clicking around, and obviously it has like an expected file and then what's actually happened. And then that's the UI testing. So that's probably still a long ways from perfect. Like there's probably other frameworks we could use. And that's why we kind of spend a lot of time in staging, testing things. But we do sort of have this mindset of trying to automate everything. So, when one framework came up, we sort of jumped on it so that we could at least automate that part of it. But yeah, it's not perfect. And I can't remember the name of the framework, but it's Robo something.
So on the topic of automation, what is your stance between continuous delivery and continuous deployment? Do you think that you will one day achieve that dream of just like, everything will be automated and land in production?
So I think a lot of people think that they're doing continuous deployment, but they're not really, because there's some restrictions, right? Like, especially in banking environments where you can't just deploy to prod when you make a change. Although that's the fear. And I think it's mainly fear that says that. But I think once all the governance is in place, so if your framework does, for example, raising a change and that change gets approved and that's part of the process and it gets approved and then you can deploy. I don't see why you'd want to not do that. Like if someone requests a feature and it's ready and it's working and it's gone through all the testing, I don't see why you wouldn't want to deploy it to production. And that's obviously what we're trying to get to. What's stopping us is obviously there is some governance around it, but I think once you sort of automate that and you put that in part of your pipeline, which is definitely possible, I don't see why you wouldn't do that. So it's definitely our goal.
Awesome. I don't see any other questions from anyone. Like I mentioned earlier, you guys can just chime in. So since we're on that slide, actually, I was actually going to ask you the next slide, business and innovation, right? And you mentioned that, in the beginning, you guys have one person perhaps working on innovation to now you guys, can just be sort of fluid and you don't really have to tell the business who is working on innovation. And is it like that within the team? Like, if I am in your team and, today I wake up and I decide to do something cool, can I just do that? Or is like, all hands on deck for the entire team to first work on business cases? And then...
So usually what would happen is, so we have these daily stand-ups, right? And the stand-ups is like we kind of discuss, we do the typical stand-up thing is sort of discuss, what you're busy on, if you have any issues, but then we also discuss like new things that we've learned about, right? So if you, for example, had seen something awesome on the net and you think, wow, this is going to make our lives easier, you would bring it up there. And then we go, wow, okay, that's awesome. Then what would happen is we would have a prioritization session. It's the Thursday before a deployment. And then we would add that item there. So we would add it as a sort of dev team requirement. So we have the business requirements, and then we've got some dev team stuff that also filters into there. And then that would come up there, and then you would work on it. So because you're the one that saw it, you think it's awesome, you want to try it, so you'd become that innovation guy. But the whole team would say, yep, that makes sense. Or like we have an architect, she's been with us for longer than what I have. She's usually the most sane person. So we come up with all sorts of crackpot ideas, and then she'll kind of, put you in your place and say, well, it doesn't really make sense, or it does. Like, she's very fair and she's very wise. And I've come up with some crazy ideas, and then she kind of says something and I'm like, oh, you're right, we don't actually need that. So, there'll be some sort of team discussion around it. People don't just run off and do whatever. I mean, if you have time, then, a lot of us do that. Like, we'll get business tasks done or whatever, then we kind of mess around with something else. But officially, if you have a cool idea and you want to take it forward, then we support you. And we'll make sure that we cover your part of the work or whatever while you go off on this cool little innovation journey, which is awesome, because then, it's just going to add another aspect to the framework, I suppose.
Awesome. So knowing what you know now, right? Now you're at the end, I won't say at the end, but in your presentation, the end of your journey, and looking back, would you sort of do the same thing again? Like, would you go start from a monolith, and then as the business progresses, you start doing this incremental change, incremental build? Or would you know that, okay, cool, microservice is the way to go. I'm going to start with microservice, so I don't have to deal with you know, the past 10 years of like schlep. But yeah.
So I think it would probably still look the way it does now. I think if we had decided early on to say, hey, we've got a monolithic application and that's bad for these reasons, and they're not always bad. Some applications should be monolithic. Like, it makes sense because everything's so tightly coupled that you might as well just keep it together, right? But I think in our case, if we had decided at this point to say, hey, monolithic for us doesn't work, we're going to rewrite this thing, we wouldn't have had the support that we had. Like, you know, they would have seen like, no, don't rewrite it, it's working fine. And then we would have sort of maybe made the relationship a little bit not so good, because people would always have in the back of their mind, these devs just want to rewrite this thing. And that's not what we did. We saw what we had and it was working. Like, I mean, it was a monolithic application, but it was still doing its job. But we sort of went on the journey and we thought, well, we can make this better and it doesn't have to stay this way. You know, the fact that it was monolithic or not, it doesn't matter. What we were trying to get was, we wanted to be able to deploy components separately. That's what we were trying to achieve. We weren't trying to achieve microservices. We wanted that. We wanted to be able to deploy the risk engine on its own, and we wanted to use that service somewhere else. That's what we wanted. We didn't want to go, microservices are the cool thing, let's break this thing apart and do that. We didn't want that. We wanted to do certain thing, and it was deploy certain things separately. So it made sense. It's kind of like, I had an example in my head and now it's gone. But yeah, so I think the journey would have probably still looked the same. And why the journey worked was because we did it that way, where we built up trust first, made sure people knew that this team, you know, wants to support the business. We're not just cowboys and we want to just deploy cool stuff. We want to support your business and we want to do it as best as we can. And this is how we think we should do it. You know, that's the approach we kind of took. So I think it would look the same.
Yeah, awesome. So Nish has a question. He asks, would you say ALCHEMY is a high volume system? Like, what is the SLA for response times?
So it's not something like a high frequency trading system, and it's not something like a Murex where they would get hundreds of thousands of FX trades a day. ALCHEMY's power is in its trade types. So the trade types are extremely complex. Like, we do CVA and DVA calculations, which need to look at an entire portfolio. And there's a lot of large trades. So I'd say it's not high volume, but high notional. So there's a lot of big value trades going in there, and valuing those trades takes a lot of computational power. Whereas valuing something like an FX swap or FX forward or something like that is a quick calculation. So we have those in the trading system, but they're used mainly for hedging bigger stuff. So the system will pick up, well, this trade has some inherent FX risk and it needs to create some hedges to protect against that risk. And in that case, we're not a high volume system. Like, there's not a lot of trades. But with the CVA stuff, what needs to happen is when you're trying to calculate something like CVA, which is counterparty value adjustment, you need to look at all the trades that are booked against a certain counterparty. And now that makes it not high volume in the sense that people are booking the trades in your system, but you're looking at the trades in other systems. And that's where the caching becomes important, where you got to take all those trades in the other systems, bring the trades in your system, and then calculate a sort of holistic CVA for all of those trades belonging to a certain counterparty, like, I don't know, Bob's Farm or something. So in that sense, yeah, then it would become a little bit more high volume, but still, that's not the intention for the system. It's more, it's the exotic trade types, the weird and wonderful type of things that take a lot of time to compute. That's where we do it. And there's a lot of sort of parallel processing that happens with these trades. There's a lot of market data calculations that happen. That's sort of our volume.
Cool, awesome. So on that, you know, high volume as well as perhaps states, like, how did you guys manage to transition from a monolithic, let's say, persistence or database to a microservice database. The state is always like quite difficult if you want to make sure that the business is always up and running, and you're trying to like do some underlying schema changes. How did you guys manage that?
So if we look at something like, let's just go to the very last one. So the risk engine itself is stateless, right? It doesn't persist any state. So the stateful part of it is when the risk engine pushes stuff into the cache, and that stuff that it's pushing is either market data or trades, right? That stuff gets sent to the risk engine, but the risk engine is stateless. It sends some serialized objects to these compute nodes, and they get computed, and then they get sent back, and then the user gets some sort of answer. When something like a schema on a trade type changes, we've got various layers where we version those layers, right? So the risk engine knows what version of nodes can compute that version of trade. So if we've got a trade type that's on a certain version, it will know which nodes is able to compute that. So when it comes through the risk engine, that serialized data gets fed through RabbitMQ in this case. When the trade picks it up, it knows that it's looking at a certain version. If it doesn't conform to that version, it doesn't pick up that work, then some other node will pick it up. So that's probably the only sort of state drama we might have, is when we trying to calculate a version of a trade on a certain compute node. But that's sort of handled by just having more nodes. And that's where Kubernetes kind of helps as well. So it can scale up nodes that need to respond to version 1 of a model or version 2 of a model or whatever. So that's not really a problem. The other reason why it's not such a big problem is because ALCHEMY is primarily using the risk engine. When other systems start, and then there's a case for it, but when other systems start using the risk engine through REST or something, that becomes more of an issue, or not an issue, but now it needs to look at the version and make sure that the compute nodes are available for that version. So yeah, so primarily ALCHEMY is stateless except for when loading those trades, but then from the risk engine onwards, it doesn't maintain that state.
Awesome, thanks. So Nish has a question on the previous discussion on trust. So he asks, from your journey, could you perhaps generate a cookie cutter recipe for earning trust and creating such a synergy with business where you can innovate as well as provide features for business?
So I think, like I said earlier, maybe is business looks for very little things, right? I mean, they got a lot of demands, but it's always under one or two categories where they want some sort of reliability, right? And they want to know when their stuff is going to get done. So that's the predictability aspect. So the reliability is kind of easy to do if you don't deploy junk. So ensure you test and so on. So that's a lot of the stuff that the devs can handle. Like, we can make sure that things are going to pass and things are not going to fail, by adding more tests. Like, that's an easy one to fix. That's on the dev side. The predictability side is a little bit more tricky, but that comes with things like Agile. So I'm just trying to get to the, I missed it. So frameworks like so like Agile or something, where you can say with confidence, and even if you're not delivering a lot every iteration, as long as you're delivering some sort of value at the end of that iteration. So what we were really bad at the beginning was estimating stuff. So we would just be yes men. We would take on a lot of things. And then we'd find at the end of the iteration, we've maybe covered 40% of the work. And then what happens is the business doesn't really trust you anymore, that you can sort of deliver on your commitments. So what we did at one point really early on is we decided we were only going to take on one business task for an iteration. And whatever that task was, that was it. We would just take on one thing and we'd make sure that we all jumped on it and made sure it got finished. And then we thought, okay, well, we finished it in 1 week, so it's not so bad. Let's take on a bit more. So sort of saying no at some point and then sort of working out what it is that you can actually do also helps. So that's what we also did. And I didn't mention that, is that at some point we decided we're only taking on one business task for 2 weeks. It would actually be and deploy it in 4 weeks, basically, the very first time, right? Thereafter, it becomes a 2-week deployment exercise. But the very first time we said, okay, well, we're only taking one thing. It's a bit shocking, but then they're like, okay, well, yeah, you didn't deliver on the last bunch of stuff you said you would. So, okay, fine, let's do that. But this was after we had sorted out the reliability drama, right? So make sure that your stuff is tested, it's in production, and even if it's half of the stuff you committed to, it's fine. Make sure that that doesn't break. And then you tackle the predictability element. And that's by saying no to just about everything until you can work out what sort of tasks can you complete as a team within an iteration. And then that sort of comes with experience. And as you get more people, those people will sort of learn as well how long it takes to integrate a model, because now there's a set formula for doing that. And the frameworks that we have where it generates the UI sort of makes it predictable, where we know the guy doesn't have to mess around with UI stuff. He just has to do the business thing, integrate the model, and push it through, right? So a lot of those things become very predictable on how long it takes to integrate something. And there's a lot of validation and other teams that need to look at the model to see if it's cool and it's tested. And then we worked out that, this 2-week period of testing kind of highlights or brings out anything that's kind of might not work. So I'd say the cookie cutter thing is probably twofold. It's make sure things are reliable, that you're pushing out quality, and then get back to the predictability. That's what business really wants. They want to know, when is this thing going to be ready? And even if you say it's in a month, make sure you deliver it in a month. That's where the trust comes from. So start small, take on as very little tasks as you can, and work out exactly how much your team can take, because every team's going to be different and every task is going to be different. So, maybe people are doing sort of web services or some website or something. That's going to be very different to what a trading system is going to do.
Great. Cool. Thanks, Jose. Guys, if you don't have any other questions, I'm going to end up the session. Speak out. Forever hold your peace. All right. Cool. Then just an ending note. So we're always looking for speakers to come and share with us their cloud native journey. This is the first one that we have done in a sort of online virtual sense. And but you can reach out to me if you are interested in doing this type of talks, where it's just Jose sharing his cloud native journey, just talking through all of the challenges or the successes that he has experienced. I think that's fantastic, and then it's cool for us to get to chat about these things, because a lot of the times, and with our previous talks, it's more like a one-way thing where you just come in and you sit and you listen and you absorb knowledge, but we like to make it more interactive. So thanks for joining us today. The webinar recording and the slides, I hope you're sharing the slides, Jose. If not, it's okay.
Yeah, no, cool. I'll share them.
Okay, cool, awesome. We'll be online over the next 2 days. So we're looking forward to seeing you at our next CNCJ event, which we're going to schedule for February, because December, January, no one's going to be around. So have a great evening, guys.
Cool.